Okay. Good morning, students. Okay. And then thank you, Manikandan, for providing alternate method, and your method is little bit short. Okay. Yes. Good morning, and it is new. So I think similarly, the remaining students also you should think not only in mathematics, in your favorite subject. Maybe it's any subject. Okay, so suppose there is one method, already existing method, then you can try, is it possible to reduce the steps, or you can find the alternate method. So in this way you can, not in all the subjects, at least you have at least one or two subjects are very interesting to you, you can try in those subjects. Okay, this is a quality for a good researcher. So, so usually the researcher will start uh, uh, to find the new things. Before find the new things, they will find the alternate ways. So if you keep on trying the alternate ways, one day you will find the new things. Okay. So this is the right path. Very good. Okay. So now we will go to our subject. If f factor is irrotational, then it can be expressed as the gradient of a scalar point function. So this is a problem we discussed the first hour. So you can write the other way. So the other way means if f factor is rotation, that means del cross f factor equal to 0, then f factor is a scalar gradient of a scalar point function. That is f factor equal to del phi. So I think yeah, we assume the f factor equal to f1 I vector plus f2 j vector plus f3 k vector. If f factor is rotational, then del cross f factor equal to 0. So from this we derive this, and we have expand this one. I think up to this step we discussed, and then I told that you should equate each component wise equal to 0. If you equate component wise equal to 0, you will get dou f3 by dou y equal to dou f2 by dou z. Yeah. Not this one. So please check it whether I am writing correctly. Suppose if I done mistake, otherwise somebody will tell. Maybe I will ask to Pragadesh, can you tell, equate the first one and tell, second one you should tell. I will write. If is Pragadesh is here?
Yes, sir.
Okay, you can tell. So
Dou f3 by dou y
dou f3 by dou y, okay.
minus dou f2 by dou z equal to 0.
Dou f2 by dou z equal to 0. This implies dou f3 by dou y
Equal to
equal
dou
to
f3.
dou f2 by dou z. Okay. Similarly, next one you can please tell the
Dou
next one. What is
f1
the
by
next
dou
one?
z
Dou f1 by dou z.
minus dou f3 by dou s
Sorry. Minus dou f3 by dou x
equal to 0.
equal to 0. This implies you will get dou f1 by dou z is equal to dou f3 by dou x. So next third
Dou
one,
f2
please
by
tell.
dou x
Dou f2 by dou x
minus dou f1 by dou y equal to 0.
equal to 0. Or this implies you will get dou f2 by dou x equal to dou f1 by dou y. So I call these three together equation 1. Okay. So now the question to everyone is, I will write here. You should tell the answer. Think and tell the answer. Equation 1 are satisfied when F1 equal to, you should tell similarly what is F2, what is F3. So, so equation 1 are satisfied when F1 equal to F2 equal to F3 equal to what? Uh, you should, the hint is here, the hint is your, this is the hint, f factor equal to del phi. Finally we prove f factor equal to del phi, so that is a hint. So using this hint, using this equation 1, uh, you should tell what is f1 f2 f3. I know that somebody will tell the answer, that's why I'm waiting. Again, I'll repeat. So you should think about
Pi as a
this. Yeah, please tell.
pi.
Sorry, rounding. Sorry, call
Pi sir, pi constant.
5. Yeah, okay. 5 partially correct சொல்றீங்க, but full correct இல்ல. It is partially correct.
Yes.
Yeah, please tell.
Dou phi by dou x will F1.
Okay. Very good. Continue பண்ணுங்க.
And F2 is dou phi by dou y.
Very good. F3 is
Dou phi by dou z.
very good, Saru Anushka. So good try. So keep it up. Okay, so your answer is correct. Dou phi by dou x. F2 is dou phi by dou y. F3 is dou phi by dou z. Okay, so you can check it. If you substitute here, suppose if I substitute here, F1, dou square phi by dou z dou x, and here F3 is what? Dou square phi by dou x dou z. The mixed partial derivatives are equal, so that's why the equation 1 is satisfied when f1 and f2 and f3 equal to this. So this implies we have f factor equal to f1. F1 is what? Dou phi by dou x into I vector plus f2 is dou dou phi by dou y into j vector plus f3 is dou phi by dou z into k vector. Okay, this implies f factor equal to, this is nothing but del phi. This is, sorry, this is nothing but del phi. So, so if f factor is, we put what? If f factor is irrotational, then f factor equal to del phi. Now, in the next problem, I am going to use this result. The next problem. Okay, write the next problem. Problem number 1. Prove that f factor equal to y square cos x plus z cube into I vector plus 2y into sin x minus 4 into j vector plus 3x z square into k vector. Is irrotational. Is irrotational. and find its scalar potential. Find its scalar potential. Okay, so there are two parts. One is you should prove that the given vector is irrotational. Okay, so that means I need to prove del cross F vector equal to 0. So del cross F vector equal to 0. So I vector, J vector, K vector, dou by dou x, dou by dou y, dou by dou z, and then component of F vector. Component of F vector is y square into cos x plus z cube and 2y sin x minus 4, and last one is 3x z square. So determinant. Okay, this is, if we expand this I vector into leave this column, leave this row, dou by dou y of 3x z square is 0 minus dou by dou z of, because this is also independent of z, 0 minus j vector into leave this column, leave this row, dou by dou x of 3x z square is x z square, sorry, 3z square, 3z square minus if you differentiate dou by dou z of y square cos x plus z cube, so this is 0, this is 3z square plus k vector into dou by dou x of this quantity is 2y cos x minus dou by dou y of y square cos x plus z cube is 2y, sorry, not 2, with respect to y, yes, 2y cos x. 2y cos x. So 0, 0, 0. So finally we'll get 0. So this implies F vector is irrotational. This implies F vector is del cross F vector equal to 0. This implies F vector is irrotational. Okay. Okay. Now I am going to use the previous theorem. If F vector is irrotational, if F vector is irrotational, then so what is F vector, Ramalingam?
Del dot psi.
Del phi. Okay, F vector equal to del phi by previous theorem. Okay. So now I am going to use F vector equal to del phi. Okay. What is F vector? Please check. F vector equal to y square cos x plus z cube into I vector plus 2y sin x minus 4 into j vector plus 3x z square into k vector equal to del phi. Del phi is I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Now you should equate the component wise. If you equate component wise, you'll get uh, y square cos x plus zq equal to, okay, first better to write dou phi by dou x is equal to, okay, dou phi by dou x equal to y square cos x plus z cube. So this implies, so next I will ask to somebody, Kirtana, can you tell what is phi? So you should integrate with respect to x. This Kirtana is here.
Sir, sin x,
Uh, uh,
sin x,
okay, y
y
square.
square, sin
Yeah,
x, y
yeah, sin
square
x y square or yes. Okay.
plus z cube y.
Uh,
Sorry, x.
yes, good. Plus,
Constant.
yeah, constant you can write. Already we discussed a similar type of problem, and I told that it is better to write instead of constant, you should write a function of y and z. Okay, because you are
Yeah.
different, you are yeah, function of y and z. Otherwise, you can write a term independent of x. Independent of x. Okay. Similarly, next dou phi by dou y. What is dou phi by dou y? 2y sin x minus 4. Is Vignesh is here?
Yes, sir.
Vignesh. Okay. Can you tell
2 sin x y
Vignesh?
square by 2
Can you try?
y square sin x
2. Very good. Very good. Very good. Y square by 2 sin x
minus
ah,
4y.
minus 4y.
A,
Okay.
a term
Plus
independent of x and z.
a term independent of
X and z.
independent of x and z.
Yes, sir.
Yes, x and z. Okay, now I think I will ask to somebody. Dou phi, sorry. Dou phi by dou z. Okay, dou phi by dou z
Sir,
is, yeah.
sir, it's a term independent of y now, sir, because it's function of x and z.
Sorry. Thank you, Bhulesh. Yeah, a term independent of here x, a term independent of y. Dou phi by dou z is what? 3x z square. Wow, 3x z square. So this implies, okay, if you integrate with respect to y, sorry, z, you will get 3x z cube by 3 plus a term independent of z. Independent of z. So here you can cancel 2 and 2, 2 and 2, 3 and 3. So I think here y square sin x is a repeated term. Similarly, x is a cube is also repeated term. Minus 4y is a non-repeated term. So already I told that the repeated term you should write only once, and also non-repeated terms you should write only once. So from these three equations, I will write this equation phi y square sin x is repeated twice. Even if it is repeated thrice, you should write only once. Plus x is a cube repeated twice, only one. And minus 4y is a non-repeated term. Okay, you should write plus some constant. Here C. So this is the final answer. So next problem. If v vector equal to w vector cross r vector, prove that w vector equal to 1 by 2 into curl v vector, where w vector is is a constant vector, where w vector is a constant vector. Okay. This is given. Okay. So first, before proving the result, first let us take what is w vector. It is given the question. It is a constant vector. So w1 into I vector plus w2 into j vector plus w3 into k vector. Okay, where w1, w2 and w3 are constants, or constants. Yeah, and r vector, it is r vector is a position vector, so that's why I'll take this xi vector plus yj vector plus zk vector. So this is r vector. So I need to prove uh, w vector equal to 1 by 2 into curl v vector. Okay, so I will take the right hand side expression RHS. So 1 by 2 into curl v vector. Okay, so this is equal to 1 by 2 into curl v is nothing but del cross v. This is v vector so del cross v vector, but we know that it is given v vector equal to w cross r vector, that is given the question. Okay, 1 by 2 into del cross v vector is w vector cross r vector. So I take this as equation 1. The left hand side is we are taking RHS. So now first I will calculate w vector cross r vector. So that is equal to determinant I vector, j vector, k vector, and then you should write dou by not dou by dou x, and then you should write w1, w2, w3, and then you should write x, y, z. Expand this determinant and write the answer. I vector into w2 into z minus w3 into y minus j vector into w1 z minus w3 x plus k vector into w1 into y minus w2 into x. Okay, so next I will take the RHS of 1, that is 1 by 2 into del cross del W cross R vector. I will write in the next page RHS of RHS of 1. Yeah. So RHS of 1 equal to what is given, half into del cross W cross R. Del cross W cross R. Okay. So now half into what is del cross W cross R? First I vector, J vector, K vector. For this del, you should write dou by dou x, dou by dou y, dou by dou z. And then W vector cross R vector, just now we got it. So first you should write, and then you should write this one, and then you should write this one. Okay. So the next page, first you should write. So please check it. W2Z minus W3Y, and then W3X W3 into X minus W1 into Z. And finally, W1 into Y minus W2 into X. Okay, now expand and get the answer. 1 by 2 into I vector into dou by dou Y of this is W1 minus dou by dou Z of this one is minus of minus W minus J vector into dou by dou X of this is minus W2. Dou by dou Z of this quantity is W2 plus K vector into dou by dou X of this is W3 minus dou by dou Y minus of minus W3. Okay, close the bracket. This is equal to 1 by 2 2W1 I vector plus 2W2 into J vector 2W3 into K vector. So take 2 commonly and cancel with remaining we have W1 I vector plus W2 J vector plus W3 into K vector. So this is equal to W vector. So this is nothing but the LHS of 1. LHS of 1. That is, we need to prove what? W vector equal to half of curl V. So, okay, so I think we proved a W vector equal to half of curl V. So proof is over. So next, write the third problem. The third problem is a little bit easier one. If A vector and B vector are irrotational, okay, prove that A vector cross B vector is solenoidal. Solution. Yes, so given what is given in the question, A vector and the B vector are irrotational. Is given the question. So this implies curl A vector equal to 0, or we can write directly del cross A vector equal to 0. And del cross B vector equal to 0. So I need to prove A vector cross B vector is solenoidal. So this implies I need to prove del dot A vector cross B vector equal to 0. So this implies we need to prove del dot A vector cross B vector equal to 0. Okay, so to prove this, I'm going to use some identity. So today morning I used some of the explained some of the identity. Now you should tell which identity is useful for this situation. Can anyone tell?
Del dot U bar cross V bar.
Sorry, Aditya, can you repeat once again?
Del dot U bar cross V bar.
Yes, correct. Del dot U vector cross V vector. Thank you. So this is nothing but V vector dot curl U plus U vector dot curl V vector. So this is the result. We know that. So now I'm going to take the left hand side. Del dot A vector cross B vector equal to, I will write B vector dot curl A vector plus A vector dot curl B vector. But we know that curl A and curl B are 0. So, and hence we got the final answer. So, the next problem is a little bit interesting and important. Determine f of r so that the vector f of r into r vector is both solenoidal and irrotational. Solenoidal and irrotational. Okay. So, if you know the idea, you can try independently. Otherwise, you can listen and I will ask some question. You can answer. Okay. At least by 2 methods you can solve. So why I am telling at least 2 method means I know only 2 methods. So that's why I told at least two method. Maybe a third method also somebody can think. Okay, first I will tell what is the first method. So R vector, let us take R vector equal to xi vector plus yj vector plus zk vector. So this is position vector, and r equal to modulus of r vector equal to root of x square plus y square plus z square. Okay, and this implies r square equal to x square plus y square plus z square. So, and we know that dou r by dou x is equal to x by r, dou r by dou y equal to y by r, and dou r by dou z equal to z by r. So we know how to get this result. So that's why I skipped that part. Directly I write, and then in the question it is given. What is given the question? Okay, f of r into r vector is solenoidal. So this is given the question. So it is a solenoidal means del dot f of r into r vector is equal to 0. So this implies, I will write in the next page. This implies del dot f of r into r vector equal to 0. Okay. Now, okay. So now, okay, I will write like this. Del dot, okay, instead of writing, what is del? Del is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. This is del dot. The first method is I am going to write f of r into r vector. R vector is what? Xi vector plus yj vector plus zk vector equal to 0. So this is the first method. The second method, is okay. First I will finish the first method and then I will tell you the second method. Okay. So here, sorry, here this is this implies I vector into dou by dou x of x into f of r. X into f of r. Okay. Lakshmi Narayanan, are you here?
Yes, sir.
Okay. Plus, please continue. I think I done the mistake. Here, after taking dot product, I vector will not come. Okay. There is some lack of concentration maybe your side. Otherwise, சார் மிஸ்டேக் பண்ணா சார் கரெக்டாக தான் பண்ணுவார்னு ஒரு நம்பிக்கை அதிகமான நம்பிக்கை வந்தாலும் பிரச்சனை வரும் சரியா so you should find suppose if I find a mistake you should tell immediately. So take a dot product dou by dou x of x into f of r. Next சொல்லு Lakshmi Narayan.
Dou by dou y of y into f of r.
Y into f of r. Okay.
Dou by dou z of z into f of r.
z into f of r, okay, equal to 0. Now UV method, okay va? UV method differentiate பண்ணு.
X
So keep x
into dou F dou X.
f into f dash of r, okay va? Into dou r by dou x. So keep x, if you differentiate f of r with respect to x, you will get f dash of r into dou r by dou x. Plus, you should keep f of r, and if you differentiate x with respect to x, you will get 1. Similarly, remaining y into f dash of r into dou r by dou y plus f dash of r into 1. Sorry, f of r into 1. So similarly, last one. What is the last one? Z into f dash of r into dou r by dou z plus f of r into 1 equal to 0. So now how many f of r? 1, 2, 3 f of r you have. So this implies 3 into f of r, 3 into f of r plus x into f dash of r. Here I think f dash of r is common. F dash of r is common. Remaining you have x into dou r by dou x is x by r plus y, dou r by dou y is y by r plus z into dou r by dou z is z by r equal to 0. So you can take r is also common. So this implies you have 3 into f of r plus f dash of r. The numerator is what? X square plus y square plus z square. So x square plus y square plus z square divided by r is equal to 0. So from this you have r square by r is r. Next page I will write 3 into f of r plus r into f dash of r equal to 0. So this implies r into f dash of r equal to minus 3 into f of r, or you can write this is f dash of r by f of r equal to minus 3 by r. If you integrate this one, if you integrate, you will get log of f of r equal to minus 3 log r plus log c, or this is log f of r equal to log of r power minus 3 plus log c, or this is nothing but log r power minus 3 into c. So this is log f of r. So f of r equal to c by r cube, or r power minus 3 into c. This implies f of r equal to c by r cube. Okay. The first part is over. So where c is a constant. Okay. So second part is what is given, f of r into r vector is irrotational. So this is also given the question. So this implies del cross f of r into r vector is equal to 0. So this is by definition of irrotational, we have this one. Okay. Now, what is del cross f of r into r vector? So this implies I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. Okay, the third row. Karthikeyan, can you tell what is the third row? The third row is what? F of r into r vector. Is Karthikeyan is here?
Yes, sir. Yes, sir.
Okay, this is nothing but f of r into r vector is what? X,
X
f of r into I vector
X f of r
plus y f of r into
plus z f
j
of r.
vector plus so here you should write what? X into
F of
f
y
of r,
into
y into f
z
of r,
into f.
z into f of r equal to 0. Okay, now this implies I vector into, if you expand this one, you will get dou by dou y of z into f of r minus dou by dou z of y into f of r. Okay, minus j vector into, leave this column, leave this row, dou by dou x of z f of r minus dou by dou z of x f of r, and plus k vector into, okay, so plus k vector into dou by dou x of y f of r minus dou by dou y of x f of r equal to 0. Now you should differentiate partially okay. So first I vector into, if you different, this is z, this is y, so you should keep z as a constant. So z into f dash of r into dou r by dou, z into f dash of r into dou r by dou. So similarly, anyone tell what is remaining? Can anyone tell? I will write here. Uh, Dhanush Kumar, Guru, Mohan Ram, Nandini, Padmanabha. Okay, Nandini. Okay. So please tell. Yeah. I vector into, I wrote the first one. So similarly, you should write, you should differentiate this one with respect to z. Okay, can you tell how I will write here?
Minus j
Y into minus y,
x y
uh,
dash of r.
dash of r. சிக்னல் கொஞ்சம் ப்ராப்ளமாக இருக்கும் சைட்லேருந்து செக் பண்ணிக்கோ. டோர் பை வாய்ஸ் சரியாக ரீச் ஆகல. டோர் பை டோ இசட் மைனஸ் j vector into
z into
okay,
f dash of r.
இப்போ கரெக்டாக இருக்கு. ஓகே, வெரி குட். f dash of r into
dou r by dou x.
dou r by dou x
Minus x into
okay,
f dash of r
correct,
into dou r by dou z.
okay. Next.
Plus k vector into
Plus k vector into
y into f dash of
y
r
into, correct?
into dou r by dou x. Dou r by dou x.
Okay.
Minus x into
Okay.
f dash of r
Correct.
into dou r by dou y.
Dou r by dou y. Okay. So correct.
Yes.
Yes, correct. Nandini, correct. Thank you. Okay, the remaining part, I think you can easily do it, because here dou r by dou is what? Dou r by dou is what is dou r by dou y? Y by r. Y by r. This is dou r by dou is, it is z by r. Substitute here I vector into, this is z f dash of r into y by r minus y into f dash of r into z by r. You can check it here. Y is at f dash of r by r. Y is at f dash of r by r. So 0. Similarly, you will get 0 in here also. Z into f dash of r into dou r by dou x is x by r minus x into f dash of r into dou r by dou z is z by r plus k vector into y into f dash of r into dou r by dou x is x by r minus x into f dash of r into dou r by dou y is y by r equal to 0. So we can easily observe that the left hand side is also 0. So that's why 0 equal to 0. If it is 0 equal to 0, what is the conclusion? So what is the conclusion? So can anyone tell? If you tell, I will write here. So who is ready to
F
tell?
of r can be any function of r in order to be irrotational.
Yes, correct, Pragdish. So f of r into r vector is irrotational. Irrotational for all f of r. F of r may be anything. Okay, so still the problem is not finished. Okay, still the problem is not finished. But here I need to write, hence f of r equal to, you should tell what is f of r, for which f of r into r vector is both solenoidal and irrotational.
C by r cubes.
C by R cube.
Yeah, C by R cube is correct. C by R cube. Because you know that if f of r equal to C by R cube, f of r is C by R cube, then f of r into R vector is solenoidal. But f of r into R vector is irrotational for all values of f of r. So if you take intersection, so you will get f of r equal to C by R cube. So I tell intersection means I think you will understand quickly. That's why I told intersection here, the word. Okay. So and for which f of r into R vector is both solenoidal and irrotational. Okay. So this is the first method. I told already there is a second method also. Just I'll give the hint. I'm not going to do everything. Okay. So the second method is del dot f of r into r vector. Okay. I don't write this one. Instead of writing this one, today morning we discussed one result. Del dot phi into f of r f vector. Okay, del dot, this is phi f vector. Del dot phi f vector is what? Del into, phi into del dot f vector plus del phi dot f vector. So using that identity, so you can easily get this is a little bit lengthy procedure. You can easily get f of r equal to c by r cube. Okay, the first part is easy. So second part also, I will tell one more method. Instead of doing this, directly once you got f of r equal to c by r cube, instead of assuming f of r into r vector is irrotational, I am going to prove f of r into, sorry, not f of r is what? C by r cube. I am going to prove c by r cube, f of r. I am going to prove c by r cube into r vector is irrotational. So that means I am going to prove del cross c by r cube into r vector equal to 0. Then the problem is over. Okay, but the second part is, this is a little bit stronger version. Okay, stronger version means here I am proving f of r into r vector is irrotational for any f of r. So I think this proof is little bit good, but there is an alternate method is also there. Okay, so you should think like this, and if possible you can try if you got the idea. Okay, and then fifth problem, find the equation of tangent plane So this is the last problem in vector differentiation. And then I am going to discuss next problem is the bending of beam. Maybe I will discuss either full problem or half of the problem today. Find the equation of tangent plane and equation of the normal to the surface, equation of the normal to the surface, x square plus x square, right here, x square minus 4y square plus 3z square plus 4 equal to 0 at the point at the point 3, 2, 1. So I think you have some basic idea about tangent plane and the equation of the normal to the surface. Maybe you studied it in the +1, +2 level. Okay, so even without my help, you can solve this problem. Okay, but anyway, I will discuss with you here. Let phi equal to x square minus 4y square plus 3z square plus 4. So this is the, I have take phi. Then find del phi. Then find del phi. Del phi is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. So if you differentiate with respect to x, you'll get what? 2x into I vector minus 8 into y into j plus 6 into z into k vector. This is our del phi. So del phi at the point 3 comma 2 comma 1. Del phi at 3 comma 2 comma 1 equal to substitute பண்ணனா வரும் 2 3 6 I vector 6 I vector 2 minus 16 j vector and then 6 into 1 6 so z k vector. Six k vector. 6k vector. So this is del phi at the point 3 comma 2 comma 1. So now equation of tangent plane at the general point x naught comma y naught comma z naught is, so please tell, if you know you can tell equation of tangent plane.
X minus x naught into I vector plus
X minus a little bit louder. X minus x naught
I
into
vector
dou phi by dou x. Okay va? Okay va? Dou phi by dou x plus y minus y naught into the direction of x. Actually, del phi is what? Del phi is the normal to the plane. Del phi is the normal to the plane. Okay, so you should write del phi is what? Dou phi by I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. So the equation of the tangent plane is actually here you should write what? X minus x naught into here you should write dou phi by dou x plus y minus y naught into dou phi by dou y plus z minus z naught into dou phi by dou z. Okay, this is equal to 0. So now we know that dou phi by dou x is 6 here. Okay, so this implies, and the x naught, y naught, z naught is what? 3, 2, 1. So x minus 3 into dou phi by dou x is 6 plus y minus y naught is 2, dou phi by dou y is minus 16 plus z minus z naught is 1 into dou phi by dou z is 6. Okay, equal to 0. So if you simplify, you'll get 6x minus 18 minus 16y plus 32 plus 6z minus 6 equal to 0. So this implies 6x, how many y? Minus 16y plus 6z, 32 minus 24, so plus 8 equal to 0. So throughout divide by 2, we'll get 3x minus 8y plus 3z plus 4 equal to 0. This is the equation of the tangent plane. So next, equation of the normal. So now you can try equation of the normal. Please, so who is trying equation of normal? It's very similar.
X minus x naught divided by dou phi by dou x.
Correct. So x minus.
X minus
Yes,
x
correct.
naught
X minus
divided by
divided
dou
by
phi by
dou
dou x
Dou phi by dou x
plus
equal
equal to y minus y naught divided by
to
dou phi by dou y
okay.
equals to z minus z naught by
Okay.
dou phi by
By
dou phi by dou z.
thank you, Rishida. So this implies we have x minus x naught is 3, dou phi by dou x is 6, y minus y naught is 2, dou phi by dou y is minus 16, z minus z naught is 1, this is 6. This is the final answer. So I think vector differentiation still, I think I finished the mathematical part. The only remaining part is we have some of the application side. So maybe I will teach application part after the second CA. So maybe tomorrow I will take some of the problems in bending of beam, but I think the time is 12:10, maybe 5 to 10 minutes. I will explain you how to solve this problem, and then you will try and get the answer. Okay. So I think I told that today first hour. So mechanical student should be ready to discuss with me. Suppose if you have any idea, and you can tell, because here not only mathematics, so physics also involved. Okay, because to form the differential equation, so you should know the basic physics here. Okay, so I think uh, I can say you are better than me in physics. I feel like this because you have very good background. Okay, so at least some of the students. So that's why I am expecting somebody should participate in the discussion here. Here, it is the differential equation is not given directly. If it is given directly, then you can easily solve the problem. So here a horizontal tie rod is freely pinned at each end. So we discussed the boundary condition for a rod is freely pinned okay. So we already discussed. So we will come to that part later. So once you got the solution, we will discuss the boundary condition later. It carries a uniform load omega LB per unit length, and has a horizontal pull So this is the horizontal pull. Okay, P, horizontal pull, capital P. Find the central deflection. Okay, find the central deflection and the maximum bending moment. Okay, taking the origin at one of its end. So this is the origin. O, origin is one of the end. Okay, so originally this is the beam. This dotted line is originally it's a beam. Okay, it carries a uniform load omega LB per unit length. So this beam is now looks like this curve. Okay, this curve. So the point n dash is transformed into n here. That this is the length y. We need to find the bending moment. This is the maximum bending moment. Maximum bending moment y. So I need to find y, and also I need to find the central deflection. Okay, central deflection. Okay, now uh, and the length is L. Okay, it is also given in the question. Okay, we'll come to the solution part. Let OA be the given beam of the length. Okay, OA is the that is we know that is L, and it is given that at each end there is a vertical reaction R equal to WL by 2. Okay, so to come with this reaction, first I will ask to you, the total length is L. Okay, the uniform load W or omega per unit length. So what is the total weight is acting on the beam? That this is my question. The length of the beam is L. Okay, omega LB per unit length. Okay, so this is a load per unit length. So for total beam, how much load is acting?
Omega L will be
Yeah, omega L. Okay, so you should tell the answer is omega L. Okay, so omega L. So half of this is what, omega L by 2. This is omega L by 2. So the one end, the reaction is omega L by 2. Similarly, the other end of the reaction is omega L by 2. So it is as per maybe this is there is something behind this, but I am not exactly clear why omega L by 2. Okay, but I feel that this is correct. Okay, R equal to omega L by 2 and both of the end. So if you want to say something, you can tell. Okay, if you want to share some idea, okay, why the theory behind, okay, why it is WL by 2, WL by 2. Okay, so otherwise we will, if you know, we will discuss tomorrow also, because we are going to discuss the same concept tomorrow also. Okay, this is the first part. This is the vertical reaction. The vertical reaction is from this side. Okay, from this side. Okay, deflection is this side. Okay, so vertical reaction is the opposite to deflection. So you should remember that one. And then the external force acting to the left of the section N dash. So this is the cross section area N dash. So what is the external force acting to the left of this side, left of N dash? Or first one, horizontal pull. This is the horizontal pull, P. Okay. Second one is the reaction, R. Third one is the weight of the portion, ON. Weight of the portion, ON. ON, the weight of the portion, ON, is equal to WX or omega X acting midway. Why weight of the portion ON equal to WX acting midway? The reason is from O to N dash, the total length is X. Total length is X. So in this ON dash, the total weight is omega X, because you know omega is per unit length. So totally omega X. Okay. So at this point, okay, so the weight of the portion ON is equal to WX acting midway. Midway means up to totally omega X. So midway means at X is equal to this point. This point is X by 2. This point is midway. That's why X by 2, this point. So I will tell you here, up to this we discussed. If you have any doubts or clarification, or if you want to say something extra, you can tell. Okay. Now, taking moments about n, taking moments about the point n, we have already we discussed the moment, bending moment. Bending moment equal to, I gave the formula EI into d square y by dx square. This is the bending moment. So that is equal to the total force. Okay, okay. what is the force, external force acting here? Horizontal pull. Okay, so in general, moment. Okay, what is the definition of moment in physics is studied? Force into
Perpendicular
maybe
distance.
yes, perpendicular distance. Aditya, is it Aditya?
Parasaran, sir.
Varasuran. Okay, thank you, Varasuran. So I think both of them from AP. That's why little bit confused sometimes. Okay, sorry, Parasaran. So F into perpendicular distance. So the force is here. The horizontal pull is the force. So P. Okay, that is P, and perpendicular distance means this distance Y. Okay, so this is the horizontal pull P. So the perpendicular distance is this distance Y, which is perpendicular to this direction. Okay. Similarly, next reaction R equal to WL by 2. I told that already. Reaction is opposite to the bending. That's why negative sign minus F force is what? WL by 2. Okay, here the force is capital P, but perpendicular distance is Y. Here I put the negative sign. The reason is reaction is opposite to the bending moment, so that's why minus. So reaction is WL by 2, that is the force, into perpendicular distance is from here to here x, that is x, that is the perpendicular distance, plus a third one, right of the portion ON equal to WX. The force is WX. Okay, the perpendicular distance is this distance O to X. O to X, that is X by 2. So once you got this differential equation, remaining part you should try. You should try to find Y first, and then using freely pinned at each end, we should find the constant C1 and C2. Once you got Y, next you should find the maximum central deflection. First you should find the central deflection and then find the maximum bending. So try to get the answer. If you got the answer, you can post in the group. We will discuss the same problem tomorrow. Anyway, I am going to solve this problem. Before I am solving, at least somebody should solve this problem and post in the group. So then we can discuss a little bit more in the tomorrow class. So this is the first problem. Second problem, maybe I will discuss, I will tell tomorrow. Otherwise, I will post in the group maybe today evening. So tomorrow we are going to discuss only 2 problems. Because only 1 hour, we have 3rd hour tomorrow. So I can discuss maximum 2 problems only. Okay, thank you. If you have any doubts, you can ask to me. Otherwise, we will meet tomorrow, 3rd hour. Thank you, everyone.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Ma.
Sir,
Thank you. சொல்லுப்பா
sir,
பிரதீஷ்
sir,
சொல்லுப்பா.
can you please explain that differential equation of the circuit which you shared in the WhatsApp, sir, 2 days ago?
வாட்ஸ்அப்ல இந்த எலக்ட்ரிக்கல் சர்க்கியூட்டா?
Yes, sir. RLC circuit parallel.
அது இப்போ எல்லாரும் போயிட்டாங்களே. நான் பெட்டர் நாளைக்கு எக்ஸ்பிளைன் பண்ணுமா?
Yes, sir. Okay, sir.
இன்னும் கொஞ்சம் முன்னாடியே கேட்டுக்கலாமே. எல்லாரும் இருந்தாங்கன்னா இப்போ இன்னைக்கு எக்ஸ்பிளைன் பண்ணிட்டு திருப்பி நாளைக்கு எக்ஸ்பிளைன் பண்ற மாதிரி இருக்கும். இந்த மாதிரி ஜென்ரலா உள்ள கொஸ்டின் கொஞ்சம் முன்னாடியே தப்பு. சரியா? நான் நாளைக்கு கண்டிப்பா அந்த டிஃபரன்ஷியல் ஈக்குவேஷன் நான் எக்ஸ்பிளைன் பண்றேன். கரெக்ட், எனக்கு திருப்பி அனுப்பி. எனக்கு கரெக்டாக எதுன்னு தெரியும். எனக்கு வாட்ஸ்அப்பில் எனக்கு திருப்பி அனுப்பிச்சு விடு. நான் பார்த்துட்டு நாளைக்கு எக்ஸ்பிளைன்
Okay.
பண்ணுறேன். ஓகே, தேங்க்யூ.
Thank you so much. Thank you.
ம்.